Hi. In our study about organic compounds, we would want to be able to talk about a particular molecule and call it by name. That name would have to be a type that every scientist, wherever they are, would agree about which specific molecule we're talking about. So we would have to learn a set of rules in such a way that we will be able to name a molecule the same way. These rules are set by the International Union of Pure and Applied Chemistry, or IUPAC. Hence, we call them IUPAC rules. Another thing is that the order and arrangement of atoms in an organic molecule determine its identity. So the name of an organic compound must also accurately describe its molecular structure. In this video, we will be learning about hydrocarbons and their nomenclature. Hydrocarbons are the simplest organic compounds which contain only the elements carbon and hydrogen. Hydrocarbons differ by their type of bonds. Alkanes contain only single bonds. Alkenes contain at least one double bond, and alkynes contain at least one triple bond. Aromatic hydrocarbons are unusually stable compounds that contain the benzene ring. Before we begin studying the nomenclature of these hydrocarbons, let us first take a look at these representations. We have propane, butane, and pentane. First, let us take a look at the molecular formula. This tells us the number of atoms of each of the elements present in a molecule. For propane, there are 3 carbon atoms and 8 hydrogen atoms. For butane, there are 4 carbon atoms and 10 hydrogen atoms. And for pentane, there are 5 carbon atoms and 12 hydrogen atoms. The ball and stick model is a molecular model that shows both the 3-dimensional position of the atoms and the bonds between them. Here is the model for propane. The black spheres represent the carbon atoms, while the white spheres represent the hydrogen atoms. For butane, we have this model. And for pentane, we have this. Next, we proceed with condensed structural formula. This shows the order of atoms like the ball and stick models above, but are written in a single line to save space and make it more convenient and faster to write. It shows the hydrogen atoms right next to the carbon atoms to which they are attached. For propane, this carbon atom here has 3 hydrogen atoms attached to it, so we write CH3. This carbon atom has 2 hydrogens attached to it, so we have CH2. And this carbon atom also has 3 hydrogens attached to it, so we have CH3. For butane, this is CH3, CH2, CH2, CH3. For pentane, we have CH3, CH2, 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 and finally CH3. It is very important to note that every carbon atom has 4 bonds, whereas every hydrogen atom has only 1 bond. In a line angle formula, a line represents a carbon-to-carbon bond and a vertex represents a carbon atom. So this is the carbon-to-carbon bond, and the vertex represents a carbon atom. A line ending in space, such as this one and this one, represents a CH3 group. To count hydrogens from a line angle formula, you simply add enough hydrogens in your mind to give each carbon its required 4 bonds. Chemists use line angle formulas because they are easier and faster to draw than condensed structural formula. So just to make it clear once more, this is a CH3 here, a CH2 over here, and a CH3 over here. For butane, we have CH3, CH2, CH2, CH3. And for pentane, we have CH3, CH2, 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 CH3. Alkanes are hydrocarbons that contain only single bonds. They are called saturated hydrocarbons because all the carbon atoms contain the maximum number of hydrogen atoms possible. In other words, there are no carbon-to-carbon double or triple bonds. Now we'll look at this table in which the first 10 unbranched alkanes are listed. Notice that the names of alkanes end in A and E. Alkanes with 5 or more carbons in a chain have names that use a prefix derived from the Greek or Latin word for the number of carbons in each chain. For example, we use the prefix penta for pentane, hexa for hexane, or nona for nonane. When naming branch chain alkanes, the longest continuous chain of carbon atoms is called the parent chain. All side branches are called substituents because they appear to substitute for a hydrogen atom in the straight chain. The substituent's name is based from the straight chain alkane that has the same number of carbon atoms. The suffix "ane" is replaced with YL. An alkane-based substituent is called an alkyl group. So here we have the table of the most common alkyl groups. For example, a 1-carbon alkane is called methane with a molecular formula of CH4. So an alkyl group with 1 carbon atom is called methyl, represented by CH3. A 2-carbon alkane is called ethane, so the alkyl group would be called ethyl. A 3-carbon alkane is called propane, so the alkyl group is called propyl. Notice that we also have isopropyl, which is very similar with propyl. They both have 3 carbon atoms, but the manner in which these carbon atoms are arranged are different. We also have butyl, isobutyl, sec-butyl, and tert-butyl. These are all 4-carbon alkyl groups, but they differ in the manner in which the carbon atoms are connected to each other. Let us now proceed with the nomenclature for alkanes. First, find the parent chain, which is the longest continuous carbon chain, and count the number of atoms. Here in this example, this is the parent chain. If we count the number of carbon atoms, we find out that there's 8. So we call it octane because alkanes would have names ending in A and E. And we use the prefix octa, which means 8. Second, number each carbon in the parent chain in a way that will give the lowest position numbers to its substituents. So let us see if we should number the parent chain from the left or from the right. If we number from the left, 1, 2, 3, 4, 5, 6, 7, 8, the substituents would fall under carbon number 4, 5, and 6. If we number from the right, 1, 2, 3, 4, 5, 6, 7, 8, the substituents would be at carbon number 3, 4, and 5. So between 4, 5, 6 and 3, 4, 5, 3, 4, 5 is lower. So it is correct to number the parent chain from the right. Next, we have to identify and name the substituents. If the same alkyl group occurs more than once as a substituent, use a prefix di, tri, etc. to indicate how many times it appears. At carbon number 3 and 5, we have 2 methyl groups, so we write 3,5-dimethyl. We use the prefix di because there are 2 methyl groups at carbon number 3 and carbon number 5. At carbon number 4, we have an ethyl group, so we write 4-ethyl. The next rule is to place the name of the substituents in alphabetical order, ignoring the prefixes. So between methyl and ethyl, ethyl comes first. In writing the entire name, use hyphens to separate numbers from words and commas to separate numbers. So the final and correct name of this molecule is called 4-ethyl 3,5-dimethyl octane. Reminder, We should double check by making sure that first, the parent chain has been found and numbered correctly. For this case, we numbered it from the right, and the parent is an octane. Next, all substituents must have been properly designated with correct carbon numbers, prefixes, and alkyl names. So at carbon number 4, we have an ethyl group, and at carbon numbers 3 and 5, we have 2 methyl groups. Third, substituents must be written in alphabetical order and correct use of the punctuation marks, such as comma and hyphen. So the substituent ethyl is listed down before the dimethyl because E comes before M. Again, the name is 4-ethyl 3,5-dimethyl octane. Let us proceed with these examples. For this molecule, this is the parent chain. So we count the number of atoms in the parent chain and number it in such a way to give the lowest possible number for the substituents. For this case, we number it from the left so that the substituents are attached to carbon number 3 and 4. Since there are 7 carbon atoms in the parent chain, it's called heptane. At carbon number 3, we have an ethyl group, and at carbon number 4, we have a methyl group. So the name of this molecule would be 3-ethyl 4-methyl heptane. For this molecule, this is the parent chain. We number it from left to right so the substituents will have the lowest carbon number possible. Since we have 5 carbon atoms in the parent chain, we call it a pentane group. We have 3 methyl groups as substituents, and they are attached at carbon number 2 twice and at carbon number 4. So we write 2,2,4-trimethyl. And so the name would be 2,2,4-trimethyl pentane. For this molecule, notice that the parent chain is oriented in a different way. Again, it must be the longest continuous carbon chain, and sometimes it can be oriented in a different manner. So since we have 9 carbon atoms in the parent chain, we call it nonane. We have 3 methyl groups as substituents, and they are attached at carbon number 2, 4, and 7. So the name would be 2,4,7-trimethyl nonane. Let us now proceed to alkenes. Unsaturated hydrocarbons that contain one or more double covalent bonds between carbon atoms in a chain are called alkenes. In naming alkenes, the suffix used is ene or in. Let us try to name this molecule. First, find the longest continuous carbon chain that includes the double bond. Second, number the chain to give the lowest number to the double bond. So this time when numbering, we give priority to the double bond. So we number it from left to right. Carbon 1, 2, 3, 4, 5, 6, 7. Since there are 7 carbon atoms in the parent chain, it's a heptene. The double bond is between carbon number 2 and 3. So we write 2. And the name of the parent chain must end in ene. So 2-heptene. Third, name all the substituents and arrange it alphabetically. Well, we only have methyl groups, and there are 2. Fourth, add the prefix to show how many groups of a particular substituent are present. So we write 4,6-dimethyl. The 2 methyl groups are attached at carbon number 4 and 6. And the name would be 4,6-dimethyl 2-heptene. How about this molecule? Let us number the parent chain. Be very careful in selecting the parent chain. Remember that it is the longest continuous carbon chain. So for this example, this is the one. We have 8 carbon atoms, and we number from the right, giving priority to the double bond. So we write 3-octene. The double bond is at carbon number 3, and there are 8 carbon atoms in the parent chain, so we call it an octene. There are 3 methyl groups attached to the chain, and they are found twice at carbon number 2 and also at carbon number 6. So we write 2,2,6-trimethyl. And the name would be 2,2,6-trimethyl-3-octene. How about for this example? Can you spot the parent chain right away? So we have 6 carbon atoms. We start numbering from the top to give priority to the double bond. Since there are 6 carbon atoms in the parent chain, it's a hexene, and the double bond is located between carbon number 2 and 3, so we write 2. There are 2 ethyl groups attached at carbon number 3 and 4. This is an ethyl group, and this is another ethyl group, so we write 3,4-diethyl, and the name would be 3,4-diethyl-2-hexene. This time, let us take a look at this alkyne. Unsaturated hydrocarbons that contain at least one triple covalent bond between carbon atoms in a chain are called alkynes. In naming alkynes, the suffix used is -ne or -ine. The rules are very much the same as that for alkenes. So first we have to find the longest continuous carbon chain which contains the triple bond. And when numbering the parent chain, we should give priority to the triple bond, so we number it from the right for this example. Since there are 6 carbon atoms in the parent chain, we call it hexyne, and the triple bond is located at carbon number 1, actually between carbon number 1 and 2. Next, to identify the substituents, we have an ethyl group attached at carbon number 3, a propyl group also attached at carbon number 3, and a methyl group attached at carbon number 5. The name would be 3-ethyl, 5-methyl, 3-propyl, 1-hexyne. Here are more examples for alkenes and alkynes. It also shows the corresponding line angle formulas for the molecules. The parent chains have been numbered for you. So go ahead and pause the video and try naming them yourselves. This is 1-hexene. This is 4-methyl-1-hexene. This is 2,3-diethyl-1-pentene. This is 3-methyl-1-butene. And this is 6,6-dimethyl-3-heptene. Let us now proceed to naming aromatic hydrocarbons. The presence of a benzene ring makes it an aromatic hydrocarbon, so let's try to name this. First, number the carbon atoms in the benzene ring to give the lowest numbers possible for the substituent. Next, name all the substituents and arrange them alphabetically, and add the prefix to show how many groups of a particular substituent are present. We number it starting from this carbon. Our priority is to give the lowest number possible for the substituents. And for this case, we also give priority to ethyl because it comes before methyl. So at carbon number 1, we have an ethyl group, and at carbon numbers 2 and 3, we have 2 methyl groups. In writing the entire name, use hyphens to separate numbers from words and commas to separate numbers. So the correct name would be 1-ethyl 2,3-dimethylbenzene. Hyphen when separating a number from a letter, and comma when separating 2 numbers. For this molecule, we start numbering from here. We have 2 propyl groups attached to carbon number 1 and carbon number 3, so we write 1,3-dipropyl, and the name would be 1,3-dipropylbenzene. For this molecule, let's try to number it. So we start from here. Again, the parent name should always be benzene. At carbon number 1, we have an ethyl group. we have two methyl groups at carbon number 3 and 5. So the name is 1-ethyl 3,5-dimethylbenzene.